Hello there. How are you doing? Welcome to Introduction to Data Science or Data Science 101. My name is Dotun Opusina and I'm the CEO of Dot and Data. I'm really excited you've decided to join this course and I'm looking forward um, to both of us actually learning in this course. I hope you're keeping safe during COVID-19 season and you're keeping all the social distancing guidelines. We are going to come through this together. Something you should know before going into this course is that this is a basic course. So this is introduce you to data science and basically make you want to explore this field some more. So let's get started. So a little bit about me. I'm a data scientist based in the USA where I work on projects in finance, sales, healthcare, and sports. Like I said, I'm the CEO of Dotun Data. It's a consulting firm that solves data science problems. I studied data science intensively at Meta's Data Science Bootcamp in Seattle, Washington last summer. I'm also getting a master's in data science in the Massachusetts area. Previously, I got a master's at Johns Hopkins University. I'm looking forward to teaching you in this course because I love the field of data science, and the more people I see within this field, the more excited I become. So thank you for joining. So a bit about this course. Like I said, this is an introduction into the field of data science for anyone. The goal is that the knowledge that you gain here would serve as building blocks into your foray into the field of data science. This course is intended to serve as a gentle way to understand the data science field and its impact on the world. Like I said, the goal of this course is to spark your interest in the field, and from there you can explore more topics and more courses by yourself. With every of the discussion I'll be giving, I'll be providing resources that would enable you understand the field better, and I hope you take advantage of them because these resources have actually impacted me in my knowledge of the field of data science. So the course is actually split into two different curriculum. The first curriculum deals with Module 1 and Module 2. And in Module 1, we'll be defining data science. So basically asking, what is data science? We'll be exploring the different parts to data science. We'll be looking at any advice to give for new data scientists. So these are the things that I wish that I knew when joining the field myself. And we'll be exploring the topic, data science, the sexiest job in the 21st century. Why is that the case? Well, you'll find out when we get there. We'll also be looking at prominent data scientists in today's world and the impact they're making within the field. From there, we go to Module 2, where we look at what data scientists people actually do. So these are data science people, or data scientists, as I would like to call them. And we're going to look at what they do on a day-to-day basis. We'll explore the data science process. So with every data science project, there's actually a process to it. And so my goal is to be able to show you the bigger process behind the data science project, so that whenever you're working on a problem, you can see those different parts to the data science project. We're going to explore a day in the life of a data scientist and see what they actually do on a day-to-day basis. From there, we'll look at the different tools and technologies that data scientists use, and we'll have a discussion around them. Finally, we'll look at different data science algorithms and figure out the different algorithms and a little bit of introduction into machine learning algorithms. So if it gets too technical, don't be too scared. It's just a little intro for you. So I hope you really enjoy this course, as I'm really excited for this field. Then we go to the second course curriculum, where we look at data science in business. So data science has a huge impact in businesses today. So you look at how companies get started in data science. We'll look at the tips in terms of recruiting data science people. So for people interested in terms of interviewing for data science roles, look at what companies actually look for. They want to explore what the final deliverable is for a data science project. From there, we go into the different use cases of data science. So in terms of the application for data science and the structure of a report. Finally, we look at the data science people themselves. I find data scientists to be very interesting people because they come with diverse skill sets and they're very flexible in terms of learning. So we're going to figure out what makes someone a data scientist and what data science people actually say. So yeah, we're going to module 1. And this module is just defining data science. So I want you to just come in, understand the basics, right? Understand the definition of what data science is. Understand why it's important. Understand why we're even having this discussion in the first place. And hopefully, you're able to understand this information and go to further modules. So what is data science? Well, data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge. Data science draws insight from many structured and unstructured data, so many forms of data, basically. And it uses that information to draw valuable insight for customers, governments, businesses. Data science is a science, but it's also an art of uncovering insights and trends that are hidden behind data. And so the more you learn the science part of data science, you become more versed in terms of when to apply what models and basically understand the arts behind data science. So like I said, data science is an interdisciplinary field. So in this Venn diagram, we have data science in the middle, and we have the different fields that are actually important to data science. So we start with computer science. So I like to believe that data science uses programming languages. And I have a background in computer science, so this actually allowed me begin my career in data science. So in terms of computer science, understanding the basics of data structures, of different algorithms is important to data science. From there, we go to statistics. Statistics is the math behind data science. And so having a good knowledge of statistics is important for data science. So understanding things like probabilities, understanding things like A/B testing, hypothesis testing will take you a really long way in data science. Furthermore, understanding machine learning algorithms is really important for data science. Machine learning serves as a building block for data science models, and this allows you to create proper analytics and proper tools for your data project. Finally, data visualization is key. With everything that is done in data science, the goal is to communicate to an end user. And with the proper visualization, with the proper storytelling, you can be able to accomplish these goals. So if you're versed in these different fields, then you have a really good chance in becoming a data scientist. So like I said, data science deals with data. And not just any kind of data, but big data. So we'll have some discussion around the statistics behind data in our present times. So the big data analytics market is set to reach $103 billion by 2003. This is because of the amount of data that is available out there, the amount of insights that can be drawn, what companies are actually doing to be able to draw these insights. The big data market is expected to grow by 20%. And so it's a growth industry, and there's opportunity for anyone looking to be a data scientist. On a day-to-day basis, right, every person in 2020 would generate about 1.7 megabytes in just a second, right? So as we are having this discussion right now, we're using YouTube platform. I'm generating data by recording this video to you. You're generating data by being on this page. You're also generating data by being on the platform in itself. And this is just one platform. Think about the other platforms that you're on. Maybe your social media, maybe your emails, maybe your phone itself, your smartphones. All of this generates data. And so just by virtue of using these platforms, you yourself are a generator of data. So the internet users generate about 2.7 quintillion bytes of data each day. We are the internet users, like I said. And right now we are generating data. So all of this data needs to be understood, they need to be massaged, and they need to be able to draw proper insight for the customers. Looking more into data in the field of data science, as of September 2019, there were about 2.5 billion Facebook users. For you guys that don't know what Facebook is, it's a social media platform where people connect with their networks all over the world. 2.45 billion active users. It's a lot of people. And these people are generating data as they use the platform. So we have to be able to properly draw insights from this data set as the data is being generated. About 97% of organizations are currently investing in big data and AI. Companies now realize the importance of big data, of analytics, and of artificial intelligence, and they're investing heavily in it. So it won't be far-fetched to see companies with a data science team, or a data analytics teams, or a data analysis team. And these different teams' goal is to be able to create insight for the company. So if you take a simple example, Netflix, which is a streaming movie platform, saves about $1 billion per year on just customer retention based on machine learning, artificial intelligence, and data science results. So you have to keep this in mind that this field is actually very important, right? Data science is useful to the business, and this is allowing different companies use it on a day-to-day basis. So this is a path to data science that I've highlighted. So this is what worked for me over the years. And what I noticed is that the different data scientists that I do meet possess the skill sets. So the first thing is programming. So I have a basic understanding of programming in either Python or R, which are programming languages. Understanding fundamental concepts like data structures, like loops, like variables, like functions would be really helpful on your data science journey. If we're taking one more step, understanding statistics, the fundamentals of statistics is important to be able to create a career in data science. Statistics is the mathematics behind data science. And so to be well versed in data science, you have to understand the fundamentals of statistics and probabilities. Understanding machine learning algorithms and models is important for your data science career. So data science uses machine learning models to be able to predict the results or to be able to draw better insight from the data. So better understanding of these algorithms is key. Then finally, data visualization is important. We have to present this data to an end user. We're not just analyzing data for analyzing sake. So it has to be presented in a formatted way, and it has to be able to communicate results to the users. So these are the paths to learning data science. You can take online courses like Coursera, Udemy, Data Camp, and I'll provide the links to this website in the resources. You can go through a degree program, right? So through universities, like getting a master's, getting a PhD in the field. And this is really helpful in terms of building a portfolio with data science projects, and also getting qualified within the field. You can also take different data science boot camps, such as Data Science Nigeria, General Assembly, and METAS. And these boot camps are intensive ways to be able to get up to speed with data science projects and also build your portfolio. Finally, you don't have to leave your workplace, or you don't have to go to a degree program. You can actually ask for more data science projects at your workplace. Since we mentioned that companies are investing heavily in data science, you can ask to be a part of the team and just learn by doing. Something that is key in all of these different parts learning data science is that you must be working on projects. Without projects, you're not a data scientist. So every one of these courses, every one of these programs, every one of these boot camps allow you to create projects and work on projects and build your portfolio. So keep that in mind. So this is the advice that we give to a new data scientist, right? This is the advice that has worked for me over the years. When I meet different data scientists that I talk to them, this is what I also draw from their discussions. So the first thing is that you have to be passionate about data, right? Data science deals with data, and there's a lot of data out there. So you have to care about the role data plays in the world. You have to care about the impact that data makes, right, in businesses. And you just have to be passionate about data. From my personal experience, I care a lot about data. I love discussing about it with friends. I love tweeting about it. I love looking and analyzing it. So you have to be passionate about it. You also have to be curious by asking important questions. So for each data science project, there's always an underlying question that you're trying to answer with the data. So your curiosity has to be there. You have to be a curious person. You have to be genuinely interested in this problem. Something to also realize is that the question you ask determines the kind of insights that you get from your data. So it's important to be able to ask the proper questions of your data to be able to get useful results. More advice I would give to a data scientist or a new data scientist is to realize that data is always messy, right? So data doesn't come in the perfect form that you would expect it to be. So there's a process of data cleaning that takes place, and we'll have some more discussion about this. And finally, you have to enjoy the data process, right? It's data science, data analysis. You just have to enjoy the process because it takes time, it's challenging, but it's also very, very interesting. So there's a discussion about data science being the sexiest job in the 21st century. So there was an article written in 2012 at the Harvard Business Review describing the impact of data scientists to business. It highlighted the presence of big data at that time and the importance to draw meaningful insight from it. And so it was looking at a company, LinkedIn, and looking at the roles that data scientists were playing there in terms of drawing insights for the company. Also, there is a shortage of data scientists, and companies are actually looking to hire data scientists within the field. And so anyone that has really good skill sets would be hired within the data science field. In terms of data science also being the sexiest job in the 21st century, it was found that data scientists are found in most relevant companies today, right? So you can look at tech giants like Google, Facebook, IBM, Apple, and so many others. They need data scientists. In the US alone, data scientists are paid high salaries, ranging from $100,000 or more. And this means that you can build a lucrative career from data science. So here are some prominent data scientists. We have Dr. D.J. Patil, who is an American that served as the chief data scientist of the United States Office of Science and Technology from 2015 to 2017. He coined the term big data, and big data definitely deals with the different forms of data, the variety of data, the velocity of data, the speed of data at which it's coming, and the veracity of data. So Dr. Patil coined this term. We have Dr. Jan LeCun, who is the director of the AI research wing at Facebook. He works on different experiments and projects that is related to data science, and is the founder of the NYU Center for Data Science. We have Jennifer Chayes, who is a distinguished scientist and the managing director at Microsoft Research. So there's so many prominent data scientists out there, and you can definitely look them up online to see the kind of work they're doing. So that was the end of Module 1, and I hope that you're still excited in the field of data science, as I am also excited to share this knowledge with you. So in this second module, we're going to be looking at what data scientists actually do, right? So we're giving you an introduction into data science. You've seen the importance of data science in itself. From there, we're going to go into figuring out what data scientists actually do. So like I said, data science deals with data, and data scientists deal with data. So what is data? Data is any set of characters, words, and number that is gathered and translated for some purpose. In data science, there are two types of data. The structured data, so these are data that is contained in rows and columns. And there's unstructured data, which is just a collection of information. So think about your text messages could be a collection of information. Your tweets, an essay that you write in Microsoft Word. There's no inherent structure to it. So these are the different types of data. So what is the data science process? Well, for every data science project, there's a strategy behind it. There's a secret behind it, right? And this strategy helps you deal with the data problem so that you can get meaningful results. Now, by having a strategy, data scientists can easily conceptualize the stage of their data science pipeline and act accordingly to generate results. So here are the stages of data science. We first have data collection and storage. We have data cleaning. We have machine learning modeling. We have the model evaluations. And finally, we have data visualization and processing. So what is data collection and storage? Well, sometimes data is not just readily provided for us to analyze. The data has to be collected. So this is done before analysis. So the data can be stock market information, social media data, house prices information, right? And so there are different platforms that actually offer this data for free, where you can download it and store it locally on your computer. So in terms of data storage, there's a discussion to be had. Data can be stored in different forms, like I mentioned. It can be stored in text files, your .txt files, or your .csv files. It can be stored in databases, such as your SQL databases. It can be stored on your computer. And finally, it can be stored on the cloud. And for those who don't know what the cloud is, it's basically data storage that is available online, where you can access your data from anywhere in the world virtually. So the next step is data cleaning. And usually when data is collected, there might be missing rows and columns or wrongly imputed information. This type of incomplete data is called messy data. And so you gotta put steps in place to clean those messy data to be ready for modeling. It is very important to clean up this messy information before running the models, because the model doesn't know actually if the data you're entering is clean data or messy data. It just works on that data sets that you give it. And garbage in is garbage out. So we have to make sure that whatever data we're putting in is actually ready for analysis. So the next step is passing the data into the machine learning algorithms. So after the data is cleaned, we pass the data into the machine learning algorithms and draw insights using those algorithms from the data. These machine learning algorithms are described as models, as they use some of the data to train themselves to be able to create valuable results. Machine learning is a subfield by itself. We'll go a little bit into machine learning, but there are people that actually get PhD in machine learning, get a master's in machine learning to become an expert in just that field in itself. And machine learning doesn't just deal with text data and CSV data. It can also deal with videos, music, and so many forms of data. So it's a very lucrative field as well. From there, we have to be able to evaluate the different machine learning models, right? And so in evaluating the models, we're trying to figure out how well the model did on the data, so we know how well we can trust the insights that are being drawn, and we know how well we can evaluate our model. So there are different evaluation metrics that are being used in terms of data machine learning models, such as accuracy score, confusion metrics, and others. Based on the score received, we can determine how confident we are in the model. And in terms of evaluating metrics, this also falls within the machine learning field. And so if you go more into trying to understand that field in itself, you would understand more of these metrics. So finally, we deal with data visualization and storytelling. So the end goal of every data science project is to be able to communicate the results to an audience. It could be through a presentation, it could be through a blog, it could be through a write-up. But at the end of the day, we're communicating this to an audience. So we have to use proper data visualization tools to describe the results and the data to the audience. Data visualization is an effective way to communicate data results. So learning the art of data visualization and storytelling will serve you a long way in your data science process. So let's look at a day-to-day life of a data scientist. So this data scientist is someone that works in Canada, and it works for a startup company. It serves as a machine learning data scientist, and I wanted to see what his day-to-day life looked like. So in the mornings at 9 a.m., he has meetings and responds to emails. So it corresponds with different teams in India and in Canada. So this should allow you have a little bit concepts in how the collaboration within data science works. You don't just have to do data science by yourself. You can work with people across the world. After that, this data scientist reads his emails and reacts to information that is necessary. Then from there, it works on data science projects that he has from 9:30 to 12 noon. So, and the kind of project could range from house prices to a salary extractor, right? And creating models that actually work with the problem. In the afternoon, it collaborates with teams on data science projects. So basically looking at the different project that this team is working on and help them fix the problem as needed. When it gets to the end of the day, I catch up on technology news and blog. So it's really important as a data scientist to be abreast on the different kind of projects that are going out there. I will also link into the chat, different blogs, data science blogs that have been useful for me, that I hope will be useful for you as well. So from here, we look into the data science tools and technology. So there are many tools and libraries that are used in data science to ensure success. These tools make it easier, obviously, to be able to work on the data science problem of things rather than like building tools from scratch. These tools include data storage tools, data programming tools, machine learning tools, and data visualization tools. So in terms of data storage tools, the data storage tools deals with tools that are used to store data before analysis. Like I described earlier, in the data collection phase, there's a data storage aspect of things. This data that you're collecting have to be stored somewhere. So the tools that are being used currently in the market are MongoDB, which is a database management system, MySQL, Amazon Warehouse Services, which is the cloud, Google Cloud, and Microsoft Azure. So these different tools allow you to collect and store the data on them before analysis. After that, we have different programming tools, right? And so data science, like I said, one of the fundamental parts of data science is computer science. And computer science deals with programming. So data science projects are programmed with a programming language. Two of the main popular languages used in data science are Python and R. Personally, I have a preference towards Python, as most of my projects are done in Python. At the same time, though, a lot of people within the industry uses R. But Python is more popular for data science projects. So keep that in mind as you're learning. These languages, both Python and R, contain many libraries that allow you analyze data, manipulate data, and run machine learning problems on the data. So it actually makes our life easier because we don't have to build different functions from start because these libraries are present. From there, we have machine learning tools, right? And in terms of machine learning tools, I want you to think of them more as libraries rather than a language. So these are within your programming languages. So they can be in R, they can be in Python. An example of a machine learning library is scikit-learn, and it contains a lot of machine learning artificial intelligence algorithms that can be used to analyze your data. We have Keras and TensorFlow. And Keras and TensorFlow deals with more complicated machine learning problems. And so in terms of that discussion, you think about neural networks or deep learning. So this is where TensorFlow and Keras come in. From there, we have data visualization tools that are used to communicate and result properly, right? So these data visualization tools include Tableau, which is a standalone tool by itself, Matplotlib, which is within Python, Seaborn, which is within Python, and Power BI. And so these tools allow you to properly visualize your data well. From there, we look at the different data science algorithms. Now, before we jump in here, I have to say, like, this is going to be a little bit technical, but it's to also prepare you for your data science experience. So in terms of data science algorithms, when we're talking about the algorithms used behind data science, we're basically talking about machine learning algorithms. And there are two main categories of machine learning algorithms. There's supervised learning and unsupervised learning. In terms of supervised learning, we're simply thinking about the process of learning from trained data sets. So let's take that back. It's a process of learning from your data. It's just that simple. I don't want to go into the deep technicalities of it. I just want you to understand it from that level. And there are two main types of supervised learning. There's what you call classification, whereby you're classifying your data sets, and regression, whereby you're trying to predict a value. So an example of supervised learning is predicting house prices, right? So trying to figure out like how much a particular house would cost within a certain region. A backstory is I actually worked on a project that did this. So I was evaluating house prices within the Boston area to figure out, based on certain characteristics of a house, can you tell how much that house would cost? It was a very fun project. Another example of supervised learning is classifying a patient as either having cancer or not. So trying to figure out, based on a patient's medical record and based on their information, if they have cancer or not. So supervised learning actually allows us to do so. Another example of a category of machine learning is unsupervised learning. And the unsupervised learning is a way of modeling our data set to figure out like the hidden structure or the hidden story behind that data. So we can get more insight about our data, and so we can learn more about our data. So I'll just give you a quick example. An example is looking at social media data. So think about 10 million Twitter users. Based on what they're tweeting, we can actually group them into different categories. The grouping them into different categories is a type of unsupervised learning called clustering. So you create different clusters or different small groups of users based on their post. So this is just a basic intro into machine learning. I hope this has been useful for you. My plan is not to get too technical here, but it's to basically give you an introduction into the kind of algorithms you would see within this data science. So we've come to the end of this curriculum. And so we'll just do a quick recap. So what have we learned so far? Well, we've defined data science and its application. We've understood what data science people actually do. We've looked at the tools that data scientists used. You also did great by looking into machine learning concepts that are utilized by data scientists. You're on your way to become a great data scientist. So this is the end of the course. You can find me on Instagram and Twitter at dotundata, or my website at dotunopacina.com. I'll be linking this also at the resources. So thank you very much, and see you in the next course.